Hi everybody, today we're going to talk about an introduction to something called literal equations. So we're going to start with something that you already should know something about, which is a formula. A lot of times literal equations are also formulas. So we're going to start with the area formula for a rectangle, which you should remember is area equals length times width. So for example, for this blue rectangle I have here, if I'm trying to find the area, I would multiply the length, which is 10 feet, by the width, which is 4 feet. And the area of this rectangle would equal 40 square feet. So that's an easy enough to use formula. Well, sometimes when we're using a formula, instead of being given length and width, we might be given area and length, like in this problem. So I don't necessarily always know the two things that give me the area. I may actually already know the area and the length, but I don't know the width. So I may have to actually solve for the width. Well, this is where literal equations come into play. I can take that formula, A equals LW, and I can solve it for W. Now this might seem a little silly because they're all variables in this case. We don't just have one variable, we have many variables. But all I'm going to do is I'm going to solve for just one of them. I'm going to isolate the one that I'm interested in. So in this case, I'm interested in isolating the W. In order for me to isolate the W, I have to get rid of this L. So to get rid of L, I'm going to divide by L. I divide by L because it's W times L, and the opposite is division, just like in a regular equation. So these L's cancel, and I end up with W is equal to A over L. In other words, to find the width of a rectangle, I can do the area divided by the length. Let's try another. The density formula. You've probably talked about the density formula in science class. If you haven't, the density formula is density equals mass over volume. So density is equal to m over v. Okay? But the question here that I'm being asked is I'm asked to find the mass if the density is 3 and the volume is 7. So I know the density and I know the volume, but I'm trying to solve for the mass in this case. And this formula is not really set up for me to do that right now. But what I can do is I can solve this formula for m. In other words, I can try to isolate the m. So in this case, I'm interested in getting m by itself. In order to do that, I have to get rid of this divided by v. To get rid of division, we do the opposite, the inverse operation, which is multiplication. So I'm going to multiply by v. And of course, if I do it on one side, I have to do it on the other side. So I end up with the formula m is equal to v times d, or d times v. And now I know that to find mass, I would multiply the volume by the density. So this is what literal equations are used for. We're basically rearranging a formula so that we have the variable isolated that we want. So we're going to start now by defining a literal equation. A literal equation is a mathematical sentence involving more than one variable. You need to fill this in on your note sheet that goes along with this introduction. We've already seen two examples of literal equations, the area formula, A equals LW, and the density formula, density equals mass over volume. Those are just two examples. Any equation that has multiple variables is considered a literal equation. So we're going to try solving a few more. Now when you solve a literal equation, they have to tell you what variable you're solving for. So you'll usually see solve this equation for A. which means A is the variable you're interested in isolating. In this case, if I want to isolate A, I need to get rid of the m. Since it's m times A, to get rid of the m, I would need to divide by m. And if I do it to one side, I have to do it to the other side. So I end up with A is equal to F over m. And that's it. That's my answer. In this case, what I'm trying to do is rearrange the formula so that one variable is isolated. Once I've done that, I'm finished. Let's try another. This one's going to be a little more complicated. Here you can see P equals 2L plus 2W, which is the perimeter formula for a rectangle. And they want me to solve for L, which means that I'm trying to isolate this L. Well, I can't do that quite as simply as I did with F equals MA. I actually have to do two steps here. So if I pretend this is a regular equation, what I have is I have something being multiplied by my variable and something being added to my variable. Usually in a case like this, what I would do is I would first try to get rid of the constant, the thing that's being added on. So that's what I'm going to do here. I'm going to start by subtracting 2W from both sides of my equation. These two W's cancel out, leaving me with just 2L, which is good, a little simpler. On the other side, something funny happens here. P minus 2W, these are not like terms, so I can't actually subtract them. So I just write P minus 2W. Now I still haven't isolated my L. I still want to get this L by itself. So I still have one more step that I need to do. I have to get rid of this 2. So to get rid of that 2, since it's 2 times L, I'm going to do the opposite and divide by 2. And now these 2's will cancel, and I'll be left with just L. But of course, if I divide by 2 on one side, I have to also divide by 2 on the other side. So that entire side gets divided by 2. So my final answer tells me that the length is equal to the perimeter minus 2W, all divided by 2. Okay, let's try another. This one is the formula for area of a triangle. Area is equal to 1/2 times the base times the height. And this time they're asking you to solve for h, which means I want to get h by itself. I want to isolate the h. To get the h by itself, I have to get rid of two things. I have to get rid of the 1/2, and I have to get rid of the b. I'm going to take care of each one of those things separately. So first, if I wanted to cancel out the 1/2, I could try dividing by 1/2. That would work, and that would cancel out my 1/2. However, on the other side, that's going to make what's called a complex fraction. It's a fraction within a fraction. And I'd rather avoid that since that's not a simplified answer. So I'm going to try to think of a different way that I could cancel out this 1/2. The other way to cancel out half is to multiply by its reciprocal. So I'm going to multiply by 2 over 1. 1/2 times 2 over 1 makes 1, so they cancel out. And on this side, I'm going to multiply by 2 over 1, or just 2. So what I end up with is 2 times A, or 2 over 1 times A, is equal to B times H. Now I still have my H here. I still have not gotten my H isolated yet, but I have to do one more step to do that, and that is to get rid of the B. And since this is B times H, I can divide by B here, and then divide this whole side by B, and I get H is equal to 2A over B. So my final answer would just be H equals 2A divided by B. So again, all we're doing here is we're isolating one of the many variables that are in a literal equation based on what we're asked to isolate. We're going to practice more of this in class. The purpose of this video was to give you an introduction, so hopefully you've had that and you've had a chance to fill out your notes sheet, and that's what I'll be checking in class. Thank you.